Hello everyone. We are group number 20 of the Senior Design 2 semester. We are comprised of Aaron Ferrer, Alonso Ramon, myself, Alejandro Jimenez Rocha, and Jay Johnson. We have a sponsor named Metalogics, and our deal is to create a cloud app that expedites prescription calculations for orthopedic surgeons. Essentially, the Metalogics hardware is supposed to use brace rings to heal broken bones. This is to correct bone deformities and other types of diseases. Their proprietary brace rings require specific calculations to get the bones back into place and heal them correctly. You'll be essentially breaking them little by little to put them back to where they're supposed to be. One requirement that we were given by our sponsor was that it would have to be in the cloud with no installation. Another constraint that we were given is that it had to be HIPAA complying, storing many patients' prescriptions, and only allowing the doctors to access them.
Our project essentially was meant to compete against Johnson & Johnson's existing software that models deformity corrections using orthopedic braces. Their software is exclusive to only their products and took 3 years to develop. Our sponsor, on the other hand, Metalogics, assigned us to create similar software from the bottom up that complements their proprietary technology, the Metalogics Revolution External Plating System. Our software would be a user-friendly web application that would have hard-coded math that will be able to process surgeon inputs and compute 3D coordinates using linear algebra to determine the orientation of the Stewart platform for the patient's corrective procedure. The software will be also a secure database that would store and fetch patient data.
Hello. So I'll start us off with an outline of this project, and I'll start us off with the security and HIPAA compliance and hand it over for the Stewart platform dynamics and the prescription calculation. So for the security and HIPAA compliance, what this diagram represents is that one surgeon can have multiple patients, either no patient or many. One patient can have one deformity, and they can have a number of prescription instances. We kept the amount of information that is represented as little as necessary to keep it more confidential, while surgeons can't access patient information that they are not entitled to. We leveraged the Django framework, which provides basic security against SQL injection and other methods. So access to any data requires login and permissions. This will be demonstrated in the demo of this project.
Based off of what our sponsor requested, we determined that we needed to solve the forward kinematics of a 6x6 Stewart platform. Solving the forward kinematics problem is the process of determining the position and orientation of the platform given a set of leg lengths. We needed to solve this problem, or it would not be possible to get the shortest path from one orientation to another. We found an open-form mathematical solution that arrives at a set of possible orientations, given a set of leg lengths, by Tae-Young Lee. The problem with this paper was that the linear algebra was relatively complex and extremely difficult to implement via code. The paper describes the process of deriving a 20th degree univariate equation from the determinant of the final Sylvester's matrix. As shown in the bottom right hand, that is the general equation for solving the leg lengths, but solving for the arbitrary constants was where the real difficulty was, as seen in the bottom left-hand corner. While the process of solving for the leg lengths was mathematically feasible, it proved to be computationally difficult.
One of the goals of the project was to have a prescription planner, essentially a PDF that would have instructions for the patient to follow at home. This was to turn a certain strut a certain few clicks, or turn another strut, or not turn anything at all, as to have the brace go in the right spots. We achieved this with Python and a library called Report Lab. Unfortunately, this was left mostly unfinished. We got a few calculations out of the way, and we were able to plug in a table, but we lacked data from our sponsor to create a comprehensive list of instructions for the patient.
Hello, this is the prototype of the Hexapod software. First, I'll show you the security and the HIPAA confidentiality. So I've created two profiles. The first is Mary Major. She has access to a patient named John Smith, and the other is Larry Lowe, who has access to the patient's Joe blogs and Jane Doe. And the biggest issue with HIPAA confidentiality is we don't want doctors to access patient data that they don't have permission to. Next, let's present the prescription calculation. I've already developed a prescription here, so I'll submit that. And let's go ahead and download the prescription over here. Let's wait for it to load, and I'll go ahead and open that. And you'll notice the strut positions that I've placed earlier are right here, and the patient's prescription is over here, giving them a day-by-day prescription to follow.
We obviously ran into several roadblocks within this project, although we ran into some major problems which hindered a significant amount of progress. One of them being that this project involved researching and understanding complex linear algebra that we had never seen or studied before. It was imperative to understand this level of math one way or another in order for us to be able to calculate solutions for our brace equations. There was also a lack of communication and insufficient guidance from our sponsor's mentor. We didn't receive the necessary documents that would have given us context towards how to approach this engineering project efficiently, which also prevented us from receiving enough data from our machine learning approach to this project. And most of all, this project's ambitions eclipsed the practical project planning behind our design. However, most of these issues could have been avoided earlier on if we disciplined ourselves with our time management. This project also involved a lot of foreign concepts that didn't give us much space to apply our electronics engineering skill set, whereas it required a lot of coding and a lot of math, especially understanding an extensive amount of JavaScript, which only one of us knew.
Please let us know if you have any questions. Otherwise, thank you for your attention.